Light is a phenomenon that we commonly disregard due to how often we come across it. But a core principle in quantum mechanics states that light can be both a wave and a particle. But how? We commonly see light as a particle, a photon. This can be seen in the photoelectric effect. When light hits a metal surface, it ejects electrons. If light were to be a wave here, we can predict that electrons are ejected depending on the intensity of the light. However, if we shine a high-intensity light at the metal for a long time, it won't eject any electrons, no matter how many photons you throw at it. Electrons seem to only be emitted if light exceeds a certain frequency, regardless of brightness. If the photon's energy is less than the metal's threshold, the electron can escape. But once you have the correct frequency, electrons are ejected instantly. This shows that electrons respond to individual photons, each with its own frequency, rather than a continuous wave. Surely this means that light is a particle, right? The double-slit experiment says otherwise. Imagine passing light through a wall with two slits. If light were to act like a particle here, we would see two patches of light spots where the slits are. The light acting as a wave, however, spreads out through the slits. This is known as diffraction. As these waves diffract outwards, they create what is known as an interference pattern. When the tops and bottoms of two waves meet, they add together, making the wave larger. But when the top of one wave meets the bottom of another, they cancel out, leaving dark spots. Diffraction is only possible with waves, therefore disproving the particle theory. The only logical thing to do now is to throw particles one at a time at the wall. This ensures that only one particle passes through at a time, making it impossible for light to be a wave. Wait, what? Particles actually exist in a superposition of all possible states, wave or particle. This can be described with a probability distribution, showing the likelihood of finding a particle as a wave or a particle. In the double-slit experiment, the wave state of light goes through both slits and interferes with itself. But when observed, the superposition collapses, revealing a single outcome of where the particle lands. Thus, an interference pattern still arises. The world of quantum mechanics is constantly evolving, with new things being discovered all the time. But remember, the world doesn't always follow the rules we may think it does. So always remember to keep exploring.